This is the Dive Into Discovery podcast, where curiosity meets insight, and every conversation uncovers a new layer of understanding.
Hey everyone, you ready to get quantum? We're going deep today into quantum computing, way past the surface level stuff.
Definitely going deep.
Yeah, we're talking about the actual potential of it all, the challenges. And to do that, we've got this huge stack of data and research facts. I'm not going to lie, I'm a little intimidated.
Yeah.
It's almost like trying to understand a whole new universe.
Yeah, it is.
But instead of stars and galaxies, we're dealing with qubits, algorithms. It's intense.
Yeah, it is a completely different ballgame, quantum computing.
So where do we even start?
Well, I think maybe we can try and help people visualize it.
Okay, yeah.
Because I think that's one of the trickiest things about quantum computing is how do you wrap your head around something that's happening on such a tiny scale?
Right. So let's start with the basics.
Okay.
I know these are the building blocks of quantum computers.
Yeah.
But instead of being just 0 or 1 like in our normal computers, they can somehow be both at the same time.
Yeah.
How is that even possible?
Well, that's where we get into the world of quantum mechanics and this concept called superposition.
Okay.
Basically, it's this ability of a quantum system to exist in multiple states at once until it's measured.
So how would you explain that to someone who hasn't, studied quantum physics their whole life?
So think about a coin spinning in the air.
Okay, yeah.
It's both heads and tails at the same time, right?
Yeah.
Until it actually lands.
Right.
So it's that in-between state where it holds both possibilities.
Yeah.
That's kind of what a qubit is doing.
So it's like having a computer that can explore every possible path at the same time, instead of one at a time like our computers.
Yeah, that's the idea.
That just seems insanely powerful.
It is.
Okay, so we've got these super-powered qubits. They're in this superposition.
Yeah.
But I know there's another piece to this puzzle called entanglement.
Yeah, this one's really wild.
Yeah.
So you have these two qubits, and imagine they're linked in a way that even if they're miles apart, if one lands on heads, the other one instantly flips to tails.
Is this like quantum telepathy for computers?
I mean, it's not quite telepathy,
Okay.
but it's definitely this really strange and powerful connection between these qubits.
And that's what allows them to do calculations in a way that our regular computers just can't even fathom.
Exactly.
Okay, so we've got these superpowered qubits. They can be in superposition. They can be entangled. They're doing their whole quantum dance.
Yeah.
But in terms of what quantum computers can actually do, what does that mean for us?
Well, we keep hearing this term, right? Quantum speed up.
Yes, quantum speed up.
And that really gets to the heart of it. So quantum computers can solve certain problems way, way faster than even our most powerful computers today.
How much faster are we talking here?
It's not just a little bit faster, it's exponentially faster.
Okay, wow. That's a huge difference.
It is, yeah. And then there's these two algorithms that people keep talking about, Shor's and Grover's. Have you heard of those?
I have, but I definitely need a refresher on what they actually do.
So Shor's algorithm, this is the one that has a lot of people worried because it could potentially crack the encryption that we use every day to keep our online information safe.
Oh, wow. Okay.
Yeah. So imagine someone suddenly being able to break the codes to bank accounts, government secrets, everything that we rely on to stay safe online.
Yeah, this is a, whoa, this changes everything moment.
Yeah, it's a big deal. And that's why there's so much research going into developing what's called quantum-resistant encryption to try and stay ahead of this potential threat.
So it's like a quantum arms race, basically.
In a way, yeah.
Yeah.
It's like we're trying to build a shield before the sword even exists.
Right. Okay, so Shor's algorithm, that's the code breaker.
Right.
What about this Grover's algorithm? What's that one all about?
So Grover's is all about searching through massive amounts of data. It can speed up certain types of searches significantly. Think about trying to find a specific grain of sand on a beach versus instantly knowing exactly where it is.
Okay, yeah, that's a powerful image.
Right. So you can imagine how useful that could be for things like, searching the internet or analyzing huge data sets.
So faster Google searches, quicker data analysis. I'm starting to see the appeal here, but there's also this term that I keep hearing, quantum supremacy.
Yeah, that's basically the point where a quantum computer can do something that's basically impossible for a classical computer to do in any reasonable amount of time.
So it's basically proving that quantum computers are superior for certain tasks.
Exactly. And Google claimed to have achieved this back in 2019, which was a big moment for the field.
So it's not just theoretical anymore.
No, it's becoming real. But there are still some big challenges to overcome before quantum computers become, mainstream.
Like what? What are the biggest hurdles that they're facing right now?
Well, one of the biggest ones is this thing called quantum decoherence. Remember how sensitive those quantum states are?
Yes.
Any little disturbance, any heat, any vibration can cause them to collapse and lose their quantum properties.
Right, like trying to build a house of cards in a hurricane, as you said.
Exactly. And to make things even more difficult, a lot of these quantum computers have to operate at incredibly low temperatures.
Like how low are we talking?
We're talking close to absolute zero, like colder than outer space.
Wow.
Yeah, and even then, errors are inevitable, and that's where error correction comes in. It's another huge challenge.
So it's not just about building the hardware, it's also about developing these incredibly complex algorithms to fix all the mistakes that these computers are prone to making.
Exactly. And when we try to figure out how well a quantum computer is performing, we use this thing called quantum volume, which takes all of these factors into account.
So it's not just about how many qubits the computer has, it's about the overall quality and stability of the system.
Precisely.
Got it. Well, building and maintaining these quantum computers sounds like a pretty intense undertaking.
Oh, it definitely is. It's like a whole new world of engineering challenges.
But let's switch gears for a minute and talk about what these things can actually do in the real world. I mean, we're seeing applications popping up everywhere, from like cryptography to climate modeling. It's mind-boggling.
Yeah, it's pretty amazing. And I think we're just scratching the surface of what's possible.
Okay, so my brain is officially full of quantum weirdness for the moment. We've covered so much ground already.
That is a lot to take in.
Qubits, entanglement, algorithms, quantum supremacy. Maybe we should give everyone a minute to process before we dive into the next level.
Yeah, let's take a breather.
We'll be right back with even more fascinating quantum insights. Stay tuned.
All right, sounds good. All right, are you ready to go even deeper?
I think so. My brain is still trying to process all that quantum weirdness.
Yeah.
But I'm definitely ready for more.
Okay, good. Because now we're going to talk about how all of this, actually plays out in the real world.
Yeah, the applications.
Yeah.
This is where it gets really exciting.
Exactly.
Yeah.
And the potential applications are just all over the map. Medicine, material science, finance, climate modeling.
Yeah, there's so much. Okay, let's start with medicine. Our data mentions this thing called quantum simulation
Oh, yeah.
that could revolutionize drug discovery. Can you explain how that works?
So imagine being able to design and test new drugs entirely in a virtual environment, simulating how they interact with the human body at the molecular level.
So instead of years of lab tests and clinical trials, you could basically fast forward the whole process.
Exactly. It could drastically speed up the development of new treatments for diseases like cancer, Alzheimer's, all sorts of things.
Wow. And it's not just limited to drug discovery, right?
No, not at all.
What else can you do with quantum simulation?
Well, think about materials science. What if you could design materials with specific properties, like super strength or flexibility or conductivity,
Yeah.
just by simulating how the atoms and molecules interact?
So you could create entirely new materials with properties that we've never even seen before.
It's possible. Researchers are already using quantum computers to simulate the behavior of molecules, and, who knows what we'll be able to create.
That's wild. Okay, so we could have lighter, stronger materials for buildings, airplanes, new types of batteries that last way longer. The possibilities are endless.
Pretty exciting.
Okay, let's shift gears for a second and talk about finance.
All right.
Because this is another area where quantum computing could have a huge impact. I mean, the financial industry relies so heavily on algorithms, right?
Absolutely.
For everything from risk assessment to portfolio optimization, fraud detection,
Yeah.
all that stuff.
And quantum computers could make those algorithms so much more powerful.
Okay, so we could have more accurate predictions, better investment strategies.
Potentially, yeah.
It's like quantum computing could change how we think about the global economy.
It's a real possibility. But it's not just about making money. Quantum computing could also help us tackle some of the biggest problems facing humanity.
Like what?
Well, think about climate change. Climate models are incredibly complex.
Yeah.
They require massive amounts of data and a ton of computing power.
And quantum computers could, supercharge those models, right?
Exactly. We could get much more accurate predictions and much better understanding of how climate change will impact the planet.
Okay, so medicine, materials, finance, climate change.
Yeah.
Are there any other areas where we might see a big impact from quantum computing?
Oh, definitely. Artificial intelligence is another one. Quantum computers could totally revolutionize machine learning.
Oh, okay, interesting. So we're talking like smarter robots, more sophisticated AI.
Potentially, yeah. And who knows, maybe even self-driving cars that can handle really complex environments.
Right. Okay, that's all pretty mind-blowing.
It is. And we're just getting started, really.
Speaking of mind-blowing, we have to talk about the quantum internet. This is something that I just, can't get over. The idea of instant communication across any distance using entanglement. It's like something out of Star Trek.
It is pretty wild. Imagine a world where information can travel instantly, securely, without any of the limitations of our current networks.
Yeah, I mean, it would completely change how we do everything, from global finance to healthcare to how we connect to each other.
Exactly. It's a really powerful concept.
But how close are we to actually making this a reality?
Well, we're still in the early stages.
Okay.
But researchers have already demonstrated entanglement over pretty long distances.
Wow.
And they're working on developing these things called quantum repeaters that can extend the range even further.
So it's not just science fiction. There are actual scientists working on making this happen.
Oh, absolutely. And the potential benefits are huge. Not just for communication speed, but also for security. A quantum internet could be virtually unhackable.
Okay, that's exciting, but also kind of scary at the same time. It's like we're entering a whole new era of technology.
Yeah, it really feels that way. And it just highlights how important it is to understand not just the technology itself, but also the potential impact it could have on society.
Absolutely. This deep dive has been such an incredible journey so far. We've covered the fundamentals of quantum computing, explored all these potential applications, and now we're talking about a quantum internet. It's mind-blowing.
And there's still more to come.
Oh, there is.
Yeah, we've got to talk about what all of this means for the average person.
Right, because it's not just about scientists and engineers anymore.
Exactly.
Okay, I'm ready for the next chapter.
So, ready to bring it back down to earth a little?
Yeah, I think that's a good idea. All this talk about quantum internets and super materials is pretty wild.
It is, yeah. But at the end of the day, we need to think about what all of this means for, the average person.
Right. Because it's not just a game for scientists and engineers anymore, is it?
No, not at all. This stuff is going to start affecting everyone's lives.
So for someone who maybe isn't a tech expert, why should they care about quantum computing?
Well, because it has the potential to change almost everything.
Okay, in what way?
I mean, it's not just about faster computers. It's about, a fundamental shift in how we solve problems, how we understand the world, how we interact with technology.
So it's not just about the technology itself, it's about the impact it's going to have on everything.
Exactly. And even if you don't understand the technical details, just having a basic understanding of the concepts will help you make sense of all the changes that are coming.
So, be informed, be adaptable, be ready for the future.
Exactly. And if you're feeling really adventurous, there are tons of resources out there for learning more about this stuff.
Oh, yeah, for sure. There are some great books that explain quantum computing in a way that, normal people can understand.
Yeah, for sure. And there are online courses, videos, articles. You can even find interactive simulations.
So if you're curious, there's no shortage of ways to learn more.
Absolutely. And honestly, that's what it all comes down to, curiosity. That's what drives scientific discovery, right? That's what pushes the boundaries of knowledge.
Well said. So as we wrap up this incredible deep dive into quantum computing, I want to leave our listeners with one final thought.
Okay, I'm listening.
Remember that we're still just at the beginning of this quantum revolution. What we've talked about today is just a glimpse of what might be possible.
Yeah, the true potential is still out there waiting to be discovered.
Exactly. So, to our listeners, I say this. Keep asking questions. Keep that sense of wonder alive. And never stop exploring. Because the quantum realm is full of possibilities. Who knows what incredible discoveries we'll make along the way?
That's a great way to put it. The future is full of potential, and we all have a role to play in shaping it.
Absolutely. And that's a wrap on our quantum deep dive. Thanks for joining us, everyone. It's been a wild ride.
What did you think of this week's episode? We'd love to hear your thoughts in the comments. Don't forget to join us next time as we dive even deeper. And as always, stay curious. because you never know what discoveries are just around the corner.